Welcome to the next lesson on radiation. Today we are looking at sources and storage of radiation. Okay, so the first thing we need to do in your notebooks is to answer the do now questions. Okay, so there's 5 of those. Pause the video, come back, and we can answer those questions. Okay, so where in an atom are the protons found? Okay, so the protons are found in the nucleus. Okay, where in an atom are the neutrons found? They are also in the nucleus. Okay, what does the mass number tell us? Okay, so the mass number is the number of protons and neutrons. Obviously, in the nucleus, okay? And the atomic number tells us the number of protons, okay? Okay, so how can you find the number of neutrons in an atom using the mass number and the atomic number? Okay, so the number of neutrons is equal to the mass number take away the atomic number. Okay, make sure you've got those in your notebook. Okay, so what causes an atom to emit radiation? Okay, so an atom becomes unstable and emits radioactive emissions when there is an imbalance in the number of protons and neutrons. Okay, so we found out last time that an unstable atom is named an isotope. Isotopes of an element have the same number of protons but different number of neutrons. So last lesson we looked at hydrogen, for example, and we saw that all the hydrogen isotopes had 1 proton but then different number of neutrons. Okay, the isotopes become more stable by releasing one of the radioactive emissions. That's alpha, beta, or gamma. And we're going to look at those later on. Okay, so background radiation. All right, so background radiation is all around us all the time. Some of it comes from natural sources and some of it comes from artificial sources. So natural sources are cosmic rays, rocks and soil, and living things. Okay, so cosmic rays come from space. They're emitted by stars. Rocks and soil. Some rocks are radioactive and they give off radon gas, which is a radioactive gas. And plants and other living things absorb radioactive materials and pass them on up the food chain. Okay. Artificial sources, we've got medical sources. X-rays are an example of that. Nuclear fallout from nuclear weapons and testing, which makes up a very small amount of the artificial sources, and radioactive waste from nuclear power stations. And we're going to look at radioactive waste and how it is stored towards the end of the lesson. Okay, so this bit of information shows us loads of different places, loads of different sources for different areas in the UK for background radiation. Okay, so background radiation isn't the same around the world, it isn't the same in the UK. For most people, natural sources contribute most of their background radiation dose. Okay, there will be some people, due to where they work, their jobs, where most of their background radiation will come from artificial sources. Okay, yeah, so people that work in medicine or radioactive industry, okay, like nuclear power stations, they will have a greater contribution from man-made or human activity. Okay, artificial sources make up only about 15% of the average background daily dose. Nearly all of that comes from medical procedures. Okay, so there are a few questions on your workbook regarding these questions, so you just need to find the information from the table, from the bar graph, and from the pie chart. Okay, you'll notice that the percentages are written in on the pie chart, so you don't need to measure. And then we need to use the scale here for this bar graph. Okay, and then obviously we've got these percentages here. Okay, right, so just some review questions. So if you could pause the video, and you should be able to answer those questions, and we'll come back once you've unpaused the video. So you should have corrected the incorrect statements. Okay, so the 3 radioactive emissions are alpha, beta, and omega. That is false. Okay, and this should be gamma. Alpha, beta, gamma. Okay. Isotopes have the same number of neutrons and different numbers of protons. That is false. Okay, we need to change neutrons to protons and protons to neutrons. Okay. Radio emissions are emitted by stable atoms. That's incorrect. It's unstable atoms. Background radiation is around us all the time. That is true. Background radiation levels are the same across the world. That is false. They are different. Rocks, food, and cosmic rays are all natural sources of background radiation. That is true. Artificial sources of background radiation can contribute nearly all on an average person's daily dose. That is false. Okay. We can change that to natural. Natural sources of background radiation contribute nearly all of an average person's dose. Nearly all artificial background radiation comes from nuclear fallout from weapons and testings. Okay, that is incorrect. So that's a false one. We'll cross that out and we can put medical sources or medicine. Okay, so we'll move on to the next part of the video. Okay, so we're looking at nuclear waste disposal now. So nuclear waste is generated when radioactive isotopes that is, have been used, often in nuclear power stations, and then they need to be stored. The waste cannot just be thrown away, as it can remain ionising for a very long period of time, so it remains radioactive for a very long period of time. There are different categories of nuclear waste. Low-level radioactive waste, such as contaminated gloves, can be disposed of in landfill sites. Higher level waste, which may be dangerously radioactive, is more difficult to dispose of, and it can be reprocessed to extract nuclear fuel or encased in glass and left deep underground. The greatest risks associated with storing nuclear waste is that it may contaminate water underground, leading to ionising radiation affecting humans, animals, and plants. Okay, so we're going to go on to our review questions now. Okay, and you need to just go through true and false for each one, and then correct the incorrect statements. Okay, so the three levels of nuclear waste are low, intermediate, and high. That is true. Okay, low-level waste is stored in pools of water. That is false. Okay, so it is disposed of in drums and surrounded by concrete. Okay, intermediate level waste is mixed with concrete and stored in metal drums. Okay, and that is true. High level waste is buried in clay-lined landfill sites. That is false. Okay, so it's stored underwater in large pools. Okay, for 20 years. Okay, these are sealed pools. We're not just going to put it in a river and hope for the best. Okay, and then they're placed into casks and buried underground. Okay, nuclear waste stays radioactive for a few years. That is false. It stays radioactive for many years, thousands of years. Okay, so what we want to do now is, using the information that you've been shared, okay, we need to go through and we need to fill in this table, okay? All right, when you've filled in the table and you've answered the questions about the background radiation, you need to submit your work in your workbook for your teacher to assess your learning, okay? If you have any problems, please write a message to your teacher and they'll be able to go to your notebook and have a look and help you. All right, thank you very much.